session in transportation engineering. So I hope you are continuing from the previous session. So this is summit curve under the topic of vertical alignment. Okay, so if you see, we are under the topic of highway engineering. We are under the last topic of geometry design chapter, under geometry design chapter of vertical alignment. So in this session we are going to see summit curves. Okay, so if you see under vertical curves, I hope if you remember I showed you in the previous session. So this is the vertical curves along the length of the road. To visualize easily, you see this will be the vertical curves. So the vehicle will travel in along the length direction. So if you see, if the vertical curves are convex, then it is called summit curve. You can see this figure. And if it is concave, you can see this figure. Okay, this is called valley curves. So if it is convex, you see from this figure there is one gradient of AD. You can see this line, blue color line, and you can see one gradient of BC. There are two gradients as a tangent. Okay, the two gradient line, I have drawn a tangent line. This is a tangent line. AD is a tangent line and BC is another tangent line, forms a summit curve. Okay, the red color is the summit curve. Similarly, the two tangent, and if you see the T1 and T2, T1 is a rising gradient, T2 almost a flat gradient, or also that is also a falling gradient. You can say in any way. We will see in 2 or 3 slides. Anyhow, this is this is how the two gradients will form a summit curve or a valley curve. Okay, so if it is a convex shape, it is called summit curve, and if it is a concave shape, it is a valley curve. So let's discuss more about deviation angle. In the previous session, I have told you the deviation, the name says the deviation angle is nothing but how much the gradient is deviating. The second gradient is deviating from the first gradient. Okay, that will give you the deviation angle. You can see from the figure 1, this is the formula for calculating the deviation angle. You can see all the figures, there are 4 figures in the slide. All the figures are summit curves. Okay, you see the first figure, there is actually this will be minus. There is one rising gradient is going above plus n1, and there is a falling gradient that is minus n2. Okay, so the deviation angle is actually this minus. There is a deviation angle n1 minus n2, n1 of minus n2 you should put. So this will give you n will be equal to n1 plus n2. Okay, so this is a one form of summit curve. You see the second form of summit curve here. So one gradient, first gradient is 0 and second gradient is falling gradient. Okay, so you can pause the video and see yourself. Anyhow, this is the second form of summit curve. So this is third form of summit curve. To find the deviation angle, you see n2 is a flat gradient and n1 is a rising gradient. Okay, so this is plus n1 rising gradient, n2 is a flat gradient. So this 2 will form another form of a summit curve. So the formula is n1 minus 0. Okay, so you see the fourth one, there are 2 rising gradients. Okay, so this should be minus. So there is plus n1 is another one rising gradient, plus n2 is another rising gradient. So this 2 will form a, you can see the deviation angle n1 minus of n2. Okay, so 2 rising gradient will form another summit curve. So these are the different ways. We can even define another 4-5 types, but anyhow, these are the different ways of forming a summit curve, and I hope you are clear with how to determine your deviation angle, because this deviation angle plays a very important factor in finding the design of summit curve, like finding the length of the summit curve. Okay, so summit curves. Now we are going to find the design, means we are going to find the length of the summit curve. Okay, so before that we have to fix some graph, we have to fix some shape. If you remember, our horizontal circular curve is horizontal curves, whatever we have studied in geometry design is circular arc shape. If you remember, circular arc shape. And transition curves, we have put a curve shape, spiral curve. Okay, spiral curve or clothoid shape we have discussed. Here for summit curve, we are going to assume square parabola. The square parabolic curves are being assumed as a shape of your summit curves. Okay, because, and also we have 2 assumptions why we got that square parabolic curve, because in summit curves the curve should be so flat that the length of the curve should be equal to the length of the chord, and the portion of the curve along the two tangents, if you see like two tangents, consider there is a two tangents and this is your summit curve. The blue color is a summit curve. The portion of the curve along the two tangents on either side of the point of intersection, consider this pink color is the point of intersection. So both sides should be equal. Okay, the portion of curve on either side of the point of intersection should be equal. So satisfying these two assumptions is our square parabolic curve. So they choose, if you remember square parabolic curve, you would have studied in your school classes, y equal to 4ax square, I think you would have studied, but this 4a is a constant. This 4ax square, consider, let us assume 4ax square. In our case, instead of a is a constant, right? We have n by 2l. So after 2-3 slides you will know how this formula came, but anyhow this is our equation of our summit curve. Okay, n is our deviation angle, l is the length of the curve. So if you know the length of the curve and if you know the deviation angle, you just substitute for different x values starting from ordinates. Consider the ordinates starting here. So starting from 0, for different x values you will have different y values. You can plot your own summit curve. Okay, so from this slide you should know there were some assumptions. The square parabolic curves were satisfying the assumptions, so our summit curve will be in the shape of square parabolic curves, and I have given a equation for square parabolic curves which we will derive in 2 or 3 slides anyhow. Okay, so summit curves are in the having the shapes of square parabolic curves, and there are some notable points you should know. For summit curves, n will be always positive, the deviation angle should be always positive, then only it will form a summit curve, and square parabolic curves are being adopted because of its simplicity for working, and also it has a uniform rate of change of grade. Okay, because it is x square, right? So it has a uniform rate of change of grade, and maintenance and drainage are not a problem over the summit curve. So for these three, there are some 3 notes you should know, because there is no issue of drainage. I hope you know, since per common sense you know, if it drains, obviously see, because of its shape it will go. So drainage will be issue only in the valley curve, not in the summit curve. And also the maintenance is very easy, because the centrifugal force will act outwards. If you remember, centrifugal force which is coming because of a circular motion will always act outside of the curve. So when the centrifugal force is acting outward and the weight is acting, weight of the vehicle will be acting downward, both are in different directions. So we are not going to have any impact damage on our roads when the road is in this direction. Okay, because of the weight the damage may come, but not because of the centrifugal force, so there is no impact. So maintenance is very easy compared to the vertical curves we are going to see in the next topic. So maintenance and drainage is not a problem in the summit curves. Okay, so having understood that, we are going to see the design of our summit curve. So what is our only problem in summit curve is our side distance. You see the driver's eye is here, so this much only he can see, but when the car is little downward, when it is the car position or the vehicle position is somewhere here, so his side distance will keep on reducing. So the only issue in the summit curve is side distance. So we have to determine the length of the summit curve required based on side distance. Okay, so both the side distance will be a problem, either if it is a stopping side distance or whether it is a overtaking side distance, both the side distance will be a problem. So we are going to see one by one. First, the factor of stopping side distance. So if you remember in setback distance, similarly we are going to see if length of the curve is greater than stopping side distance. Okay, the curvature is very high compared to stopping side distance. IRC has given a formula ns square divided by square root of 2h plus square root of 2 small h whole square, where capital H is the height of the eye of the driver, which is 1.2 meter, and small h is the height of the object, which is 0.15 meter. So if you substitute these values, you will get a formula. Length of the summit curve is ns square divided by 4.4, where s is the side distance, n is the deviation angle. Okay, so this is case 1. For case 2, when your length of the curve is less than the stopping side distance, so this is the formula given by IRC to determine the length of the summit curve. And if you substitute the capital H value of the height of the eye of the driver is 1.2 meter and small h value of 0.15 meter, then you will get the same equation something like this: 2s minus 4.4 divided by n, where n is the deviation angle and s is the side distance. So remember, if they are changing the values of h and small h in your GATE exam or any other exam, the number 4.4 should change. So remember, they have changed in 2018, I think. So they have changed the height of the object to 0.2 meter. So the number will change. So try to memorize the equations given by IRC itself instead of memorizing n square by 4.4. Or if they didn't change, then n square by 4.4 is a very simple formula. You just need to know L is greater than SSD, L equal to n square by 4.4. Problem over for summit curve. Okay. So next case. So second criteria is overtaking side distance. Okay. So overtaking side distance. Okay, this is also overtaking side distance. So same formula, only difference you can see from the previous cases. Now there is another vehicle is going, and instead of assuming height of the object is 0.15 meter, we are going to assume as a height of the eye level of a driver as 1.2 meter. So both the height of eye level of driver is 1.2 meter now in this case. So if you substitute capital H is also 1.2 instead of small h also 1.2, we get the number as 9.6. So this is the only difference from previous case. Initially for stopping side distance we had a formula of n square by 4.4. Now this is n square by 9.6 for the length greater than OSD. Exactly, when length lesser than OSD, 2s minus 9.6 by n. So for stopping side distance case, it was 2s minus 4.4 divided by n. So the only difference between stopping side distance and overtaking side distance is there was a height of the object was 0.15 meter. Here we are assuming height of eye level of a driver as 1.2 meter. So there is a quite difference, so that the numerical value that 9.6 came instead of 4.4. Okay, so hope it is very simple to memorize. So now if you are having a formula sheet or put on formula sheet, write yourself under summit curve. You can write 4 cases. If length of the curve is greater than SSD, n square by 4.4, like that. So you can have 4 formulas. Length of the curve is less than OSD, we will have 2s minus 9.6 divided by n. So knowing only these 4 formulas and where it come, so complete the summit curve. Okay. So finally I should tell you something about how the equation of summit curve has been evolved. So I will tell you in short. You can pause the video and note yourself. This is just an algebra. You see this is the summit curve. The line, red color line, what I am drawing is the summit curve, and this pink color line is the horizontal line. Okay, so green color line is y dash, blue color line is y. Okay, so there are 2 equations you should know. Y dash is different, y is different. Okay, y is the distance from the tangent line, y dash is the distance of the summit curve from your horizontal lines. Okay, from your actual horizontal ground line. So knowing this, then you come back to the equation. So we know it is a square parabolic. So you see y dash equal to ax square plus bx plus c. Differentiate once, so you will get a gradient, right? So and remember, this gradient is n1 and this second gradient is n2. Remember this there are 2 gradients, n1 and n2. At x equal to 0, the gradient is n1. At x equal to L, at the length of the curve after you found x equal to L, the gradient is n2. So there are 2 gradients, n1 and n2. So if you differentiate, then you will have equation 2ax plus b. C will go anyhow. So at x equal to 0, we know slope equal to n1. If at x equal to 0, the slope is also 0, right? dy by dx is also 0. So in that case, you will get n1 equal to b. Similarly, at x equal to L also the slope is 0. Then you will get, sorry. So at x equal to 0, dy by dx you will get, it should be dy dash by dx you will get at x equal to 0. So this term will go 0. So you will have b, which is nothing but n1. At x equal to L, you will get slope n2. Okay, so at x equal to L, you substitute 2a instead of xl, plus instead of b you can even substitute n1, right, equal to n2, correct? So if you substitute, you will have your a equation, a equal to n2 minus n1 divided by 2l. and if you substitute x equal to 0, y equal to 0, you can see the equation, you can already say that, so c will become 0. So now you got two constants, a is equal to n2 minus n1 divided by 2l and b equal to n1. So you got two constants, you can substitute in that equation. You will have y dash equal to n2 minus n1 divided by 2l into x square, because we know y dash equal to ax square plus bx plus c. C is 0, so when you substitute you got y dash. So from the figure you can determine y equal to something and then do some algebra. Finally you will have equation of y as n is nothing but the difference between the tangents, right? So n by 2l into x square. Okay, so similarly, to determine the highest point on the summit curve, you have to differentiate the y dash equation equal to 0 and then you will have your x value. Okay, so if you want to find where the highest point will reach, that is the x value, you just substitute n1 l divided by n, you will have your the highest point. Okay, so you can pause the video and do this algebra yourself. So it is very simple, it's just a school level mathematics. You take the parabolic equation and differentiate and substitute the boundary conditions, you will have your y equal to, this is equation of parabola or equation of summit curve. Okay, this equation is for finding the highest point in the summit curve, where the crown point will reach. Okay, so there are two types of problems you can exploit. One is finding the length of the length of the summit curve, or to find this setting out of the summit curve, where the crown point will reach. Okay, so we'll solve few problems here. There is a vertical summit curve is formed at the intersection of two gradients is given. You can pause the video actually and solve yourself, and then you can come back. I will solve as continuously. So there are two gradients, plus 3% and minus 5% they have given, and the design speed of the two-lane two-way road is, you see, two-lane two-way road is 80 km/h, and the driver reaction is 2.5 seconds. Okay, and the friction between the tire, everything is given. So the first question they are asking is SSD, and for calculating of SSD, don't try to include the gradients. Gradients is totally different concept. Here, okay, here there is not a single gradient. You are going to determine the length now only. Okay, so based on this side distance only, you are going to determine the length of the summit curve. So no need to include the gradient. If you remember, f or plus or minus n% was there. When you are solving a summit curve or valley curve, no need to include the gradient inside. So v, you know, v, they have given 80, you can convert to meter per second. You know, time 2.5 seconds. So substitute everything, you will get your side distance. Okay, so from there you will go to the second question. We will assume length of the curve is greater than SSD. Since nothing is given, then you find ns square by 4.4, which will give you some length of the summit curve, and check whether it is lesser than SSD, then our assumption is okay. Okay, so this is what your step 1 you have to do, and step 2 you have to do, step 3. Okay, so we'll go and see the problem answer. So you see v is given, it is 22.22 meter per second. So v2 plus v square by 2gf. As I told you, no need to include the gradient. Based on this side distance only, we are going to find the length. So it's quite simple question. Vt plus v square by 2gf, you substitute, you will get 127 meter. And remember, in the question they have given safe stopping side distance. Safe stopping side distance is nothing but ist. Okay, so to avoid, if they are in the question, if they are asking you to find a side distance to avoid collision, then also they are asking intermediate side distance. If they are asking safe stopping side distance, also they are asking ist. If they are asking intermediate side distance, also they are asking ist. Okay, so include that. 2 into side distance will give you 2 into 127.45 meter, which will give you 255 meter. Okay, so then for the second question, step 1 is find the deviation angle. Deviation angle, I hope you know, n1 minus n2. In our case, 3% minus of minus 5%, which will give you 8%. So 8% is nothing but 8 by 100. So we know that we are going to assume length will be greater than SSD. So we know the formula, n square by 4.4. So in that way we got 1182 meter, which is obviously greater than 255 meter. Since we assumed the same, our assumption is correct. So the answer is 1182 meter. Okay, so this is how we got these two answers now. Okay, So I hope I made you clear. Step 1, you have to find the stopping side distance and look for the question whether they are asking you for intermediate side distance or overtaking side distance or any type of side distance. So clarify that, find your side distance, come to the second question for summit curve. For summit curve is quite simple. Step 1, always find the deviation angle. Step 2, find which case it is, whether we have 4 formulas right in your formula sheet. So pick the case and substitute, that's it. Second question, you see there is a parabolic curve, question number 34. A parabolic curve is used to connect a 4% upgrade and 2% downgrade. Okay, so for there is a 4% of rising gradient going like this and 2% of falling gradient coming like this. The highest point on the summit curve is at a distance of dash. So they are asking the highest point of the point on the summit curve is at a distance of horizontally from the first tangent point. Where is the highest tangent point? Okay, so this question you can pause the video and solve yourself. This question can be solved in 2 ways. Okay, so if you see one way, this is another way. Okay, I hope one way you know the formula n1 L by n. First step 1, as usual, find the deviation angle. Deviation angle is going plus 4 minus 2, right? Plus 4 minus of minus 2 will give you 6%. And we know the formula for the highest tangent point, or we can even say similar triangle, right? Okay, so if the total length is, okay, I will come to that. So anyway, x1 n1 into L by n, n1 is 4%, length of the curve is 150, deviation angle is 6. When you substitute, you will get 100 meter. Okay, that is direct formula substitution. This is not a formula, we have derived in our setting out terms. Another way is they have given for 6% it is 150 meter. Correct. For the total deviation angle of 6%, total length of the curve is 150 meter. Okay, so they are asking at 4% where is the crown point. For 4%, obviously it will be at a distance of 100 meter. Okay, they are not asking the height, so they are asking only in the x-axis. So there is easy to find. In x-axis, when 6% slope was there, it is 150 meter. So at 4% slope, where it will be? It will be somewhere here. How much? So you can easily do the aptitude, you can easily determine this is 100 meter. Okay, so this is another way of solving. Quite simple, no need to use formula, only using common sense we can determine. For 6% deviation angle 150 meter, so for 4% it should be at 100 meter. Okay. Okay, so next question, a summit curve is formed at the intersection of 3% upward gradient, okay, plus 3% and 5% downward gradient. To provide a stopping side distance of 128 meter, the length of the summit curve will be dash. So I think it's straightforward. Stopping side distance is given. Deviation angle, I hope you know, n1 minus of minus n2 will be n1 plus n2, which is 8%, is 8 by 100, which is 0.08. Assuming length is greater than SSD, we know it is n square by 4.4. You just substitute everything. N is 0.08. Side distance is 128 given, divided by 4.4, it is 297 meter. Okay, so this way you can take your problems book and you can solve for OSD. The number only will change is 9.6, and also you can solve problems for more problems in setting out. Okay, so the first reference I will give you is take Khanna and guess 2. Solve all the problems before going into your whether RRB or SSC or any type of exam. Try to solve Khanna and guess 2 books problems in this topic. At least 5 or 6 examples will clarify, but all the formulas have been covered. You will be using the same formulas. Okay, so we will see value curve in the next session. Thank you.